We are in 12:1 of McGraw-Hill Geometry Tennessee Reveal. All right, this is sample spaces. Basically, you're looking at kind of naming everything that can happen in a set. Like a coin. A coin has two sides to it. You got the head, you got the tails. So that would be the sample. A six-sided die. You got 1, 2, 3, 4, 5, 6. Those are the possible, things, possible outcomes. So basically, you know what an experiment is, which is a situation involving chance. And you know what an outcome is, and that's the result of a single event happening. They're going to say right here's a single performance or trial of an experiment. All right, sample space is the possible things that can happen, possible outcomes, like a goodness, I can't even talk today. Like a coin having a heads and a tails. I think it's actually where they start. All right, you know what finite sample space and infinite sample space are. We're going to talk about that really in depth. Also, continuous and discrete. We're talking about that. All right, so let's just kind of jump into it. All right, so a sample space that contains countable is finite. A sample space with outcomes that cannot be counted is infinite. That's because there's no way to count. It keeps going and going and going. Now, people get that right there, infinite and continuous mixed up. That is not the same thing. We'll end up talking about that later. All right, so let's just get into it. Example number 1. Also did that kind of for us, well, at least part A. All right, we says to define a sample space. So a fair die is tossed once. Sample space is the possible outcomes. It can land on a 1, a 2, a 3, a 4, a 5, and a 6. That's your sample space. Then in part B, it says, what is the sample space for the event of rolling a prime number? So of these 6, 3 of these numbers are prime. And a prime number is a number that is only divisible by 1 in itself. Composite is a number that's divisible by other numbers besides the number in it and 1. So 2 is prime, 3 is prime, and 5 is prime. Those are only numbers that are divisible by that number in itself. Okay, so there's example number 1. This is your sample space. Again, this is your possible outcomes. And then these are your events. So you got, a 2, a 3, and a 5 being a prime number in these possible 6 numbers on the die. All right, example 2. Kimby has a black cat and a red hat. He chooses one hat each for each day. Saturday and Sunday represent the sample space for this experiment by making an organized list, a table, and a tree diagram. Okay, so the first thing is a list. So we're going to make the organized list, each pair of possible outcomes for Saturday and Sunday choice of the possible outcomes from Sunday's hat choice, choosing coordinates. Okay, so it looks like on Saturday he can wear a red, and on Sunday he can wear the same red hat. So let's say Saturday he wears red, but on Sunday he decides to wear black. The third possible outcome is he wears black on both Saturday and Sunday. And then the last possible outcome is he wears black on Saturday, red on Sunday. So this is your sample space for having 2 things, like 2 different hats on 2 different days. All right, now they wanted to make that into a table. Now you've done this before. When you guys get into like physical science and things like this, they do this a lot with eye color. So, blue eyes, green eyes, that kind of thing. But same concept here. You've got your Saturdays, which is a red hat or a black hat day. And then you got a Sunday going across, which is either a red hat or a black hat day. Okay, so first thing you see is that the person will wear a hat red for Saturday and a hat that is red for Sunday. So red and red match up together. This blank right here would be looking at red coming across and black coming down. Okay, this block right here is for black coming across. That's what the B stands for. And red coming down. And then, of course, this box right here, the black and the black, is for black coming across and black coming down. This is your table. All right, so this is your list. This is your table. Next is the tree diagram, and we use these a lot in statistics to look at the possible outcomes. So for any of you guys that are going to take statistics, especially if you're doing a double up your sophomore year and you're with me and you're eligible to take statistics, sales statistics your junior year next year, you will have me. If you're waiting to take that in your senior year, I'd love to say it's going to be me, but year number 30 is next year, so I will be retiring at the end of next year. You will not have me. With that being said, all right, you got your red hat, you got your black hat. All right, well, if you wear red on Saturday and red on Sunday, you've got red, red. If you wear your red hat on Saturday and then the black hat on Sunday, you've got the red, black. If you wear your black hat on Saturday and then you decide to wear your red hat, oh my goodness, why isn't it showing up very well? On Sunday, then it's black, red, and then you can wear your black on Saturday, black on Sunday. So it'd be black, black. I'm not sure why that's not showing up very well. Even if I make it smaller, that does not look right. Goodness. Well, if you watch any of my videos, you'll notice that I hear me say it a lot. They didn't do a very good job of putting this in to McGraw-Hill. All right, the check at either the bottom of the page or the next page. Mine looks a little bit different than yours. Okay, so we've got group work. A geometry teacher always breaks her class up into red, yellow, and blue groups for class projects. Represent the sample space for the next 2 class projects by making an organized list. Okay, well, this is very much like this red, 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 black. You'll notice, and this is kind of how I work it every time, they kept R first, and they kept R first. Then they changed it to black first, and then black first, just to be consistent. So I'm going to do the same thing. Red is going to be first. Well, you can follow a red with a red, or you can follow a red with a yellow, or you can follow a red with a what? A black. All right, well, what happens if yellow is first? Well, yellow can go with red, yellow can go with yellow, or yellow can go with black. So I try to be consistent with red, red, red up front. This will be yellow, 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 and this will be black, black, black. But then on the second letter, I'll always keep those consistent as well. Red, yellow, black, red, yellow, black, red, yellow, black. Okay, so this will be yellow. Whoa, that is not a Y. All right, yellow. We've already got yellow, red. There's my red. Now I want yellow, yellow. All right, last one is yellow, but it's going to be red, yellow, black. So it'll be with a black. So yellow, black. All right, now I've got all of my yellows done up front. So it is red, 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 yellow, yellow, yellow. Now it's going to be black, black, black with red, yellow, black. So black, red, black, yellow, and black, black. Okay. You might have any questions? Shoot me an email. All right, example 3. Okay, it says, okay, this is where I need to, I guess, classify it better as finite, infinite, and then discrete and continuous. Okay, so finite means that it can be counted. Infinite means that it cannot be counted. Discrete means that it's countable. So if it's countable, then you got to decide if it's finite or infinite. So one more time, discrete means you can count it. Finite means that you are going to count it and you're going to be able to count it. And then infinite means it just kind of keeps going and going and going. It's not really, able to do it. Continuous means you're measuring something. Now, you guys that are going to go into statistics for sales or sales statistics, we do a little bit of this, discrete and continuous. There's a very few lessons on it. So discrete, remember, countable, continuous is measured. Okay, so if you're wondering what the difference is, discrete, I can count how many noodles that I have in a bowl. Continuous is, like my height. I'm a very short woman. You would measure how tall I am. So I would be continuous. That was going to be measured. All right, so let's get into it. A marble drawn from a bag that contains 3 orange marbles, 5 green marbles, and 4 blue marbles. Okay, so there are only blank possible outcomes for this experiment. Well, that's 3 different marbles. So there's 3 different possibilities: the orange, the green, the blue. Selecting an orange, green, or blue. So there's only 3 different things you can pull. You can only pull one of those 3 colors. The sample space S is, this is finite. It's finite because it's countable. I can definitely count how many are there. So that's fine. Finite. All right, B. A spinner with 4 equal parts of green, blue, red, and yellow is spun until it lands on yellow. All right. There are a number of possible outcomes of the experiment. So, okay, this is infinite. This is there. I mean, I can keep spinning and spinning and spinning, and so yeah, I can keep spinning and never stop. So there's an infinite number of possible outcomes for this experiment. So the sample space is infinite. Because the experiment ends after a certain number of spins, when the spinner lands on yellow, the sample space is, this is because it's a countable type thing that is discrete. It's not measured. Measured would be continuous. Discrete means it's countable. All right, so you can count how many times you land on green. You can count how many times you land on blue or yellow or red. All right, so being that you want to land on yellow, that makes it infinite. All right, part C. Okay, a ball is thrown into the air and its height is recorded in inches. Okay, well, I'm about to measure this because this is something that I would have to measure. I wouldn't count how tall it is. I would measure how tall it is. So that last answer is going to be continuous for sure. I can't spell continuous. There we go. All right. So now it comes down to, is it infinite or is it finite? All right, well, this is infinite. There, okay, I'll throw it up once, I'll throw it up twice, I'll throw it up 3 times, I'll throw it up 10 times, I'll throw it up 20 times. I mean, is it really, am I going to have it the same height every single time? No, that's infinite. So the sample space is infinite. And just keep throwing and throwing and throwing and throwing and throwing. All right, but when I measure something, that is continuous. So one more time, discrete is countable. Continuous means I'm measuring it. All right, where am I going? Example 4, I guess. Example 4. Okay. Santiago lists the number of sections available for the courses he will take in his first semester at college. How many different schedules could Santiago create for this semester? Okay, so he's got 6 sections offered in art history. I'm looking right here. 5 in French, 9 in math, art 4, and English 6. Okay, what's my first question? All right, you can estimate. Oh, God. If y'all know me, y'all know I hate estimation. God, I hate estimation because it's not a real answer. Or you can estimate the total number of different schedules he can make. There are about 10 sections of the what course? Well, there's no 10 over here. The closest one would be 9, which is mathematics. All right, for each of the other 4 courses, there are about how many sections offered? Okay, well, I'm looking at 6, 5, 4, and 6. I guess the middle number would be about 5. There's a 5, and there, 4 is one below, and 6 is one above, so I'll go with 5. There's about 5. All right, multiply to estimate what Santiago could create about how many schedules. Well, okay, so if we made this 10, again, I'm estimating, and I made this 5 and 5 and 5 and 5, I'm going to multiply 5 times 5 times 10 times 5 times 5. All right, did you get that? 5 times 5 times 10 times 5 times 5. All right, 5 times 5 times 10 times 5 times 5. 5 times 5 times 10 times 5 times 5. All right, let me go grab a calculator. Oh, 10 times 5 times 5 times 5 times 5. That's going to be 6,250. Okay. Again, that's an estimation. And if you guys know me, I mean, you've heard me probably say it a bazillion times, I hate estimating. I'm, as a math teacher, as a math person, we want to find the actual answer, which is about what we're about to do here. Yes, because it's going to be a totally different number of possible outcomes. All right, find the number of possible outcomes by using the fundamental accounting principle. Love it. All right, that means I'm replacing my estimation with the actual 6, 5, 9, 4, 6. 6, 5, 9, 4, and 6. All right. So that means this is the real possible outcomes, 6,480. Okay. I'm going to check here. All right, clothing. A sneaker company lets you customize your own sneaker on their website. Using their most popular sneaker as the base, you have the option to customize the color of each part of the sneaker. Okay, so we got 20 main colors, 12 different bases, 29 different size, 12 different toe caps, 2 different types of soles, and 29 different laces. All right, so best estimate. Oh, gosh. I hate estimating. God, I hate estimating. Well, it's definitely not A or D. That doesn't make any sense. So grab a calculator, multiply to find the real answer. 20, 12, 29, 12, 2, and 9. Is that part B? Thank you, Lord, have mercy. All right, so I'm going to multiply all of those, and I get 4,844,160. Now, there's the real answer. Now, when you're estimating, obviously, you're not going to get the real answer. You're looking for something that's pretty close to it without going over. So I guess without going over, it would be the 3,600,000. Okay, there you go. Closest to it. Boom. All right, what's up next? Oh, okay. Next up is your practice. All right, you guys, that is on you. That is going to be in McGraw-Hill, and I've labeled it 12-1 sample space practice. All right, good luck. And if you have any issues, let Ms. Gitchell know, or you can email me. All right, have a good one, y'all. Good luck.